great. Alright, we got our paper here. There's a puppy. Just draw this right here. And a remote control car. The puppy is moving at a constant speed towards the car at 4.85 meters per second. Now, the toy car only starts accelerating, which means this is stationary, until this distance is 32 meters. Once this is 32 meters away, the puppy from the car is gonna accelerate away from the puppy at 0.165 meters per second squared. Now it asks, when does the puppy catch up to the car? Okay, well, it basically says that the puppy will catch up to the car at some point because this is accelerating from 0. So at the start, it's not moving, but it's accelerating very slowly. So it'll be moving like this. And the puppy is moving fast so that it'll catch it first. But the puppy is staying at the same speed, which means eventually this car will keep speeding up. It'll eventually catch the puppy. So there's 2 points when the puppy and the car will be right next to each other. If we say that, if we start at this point when it's 32 meters, this is when time is 0. We can just say this point is when t equals 0. And then we can say that our x reference point, which means just any x value that we get will be that value away from this point. It's like right now, this is at 32, this is at 0. Because this is 0 meters away from the reference point, x ref. And this is 32 meters away from our reference point. So we can show that by setting our axes. We say that this is the x direction, positive x direction, and this is the y positive direction. So, first, we want to find where these two are going to be at the same x reference, or at the same x value, which means the same distance from this x reference, which means that's the same thing as saying when are they next to each other. So for any position of the puppy at any given time, because the velocity or the speed that the puppy is going at is 4.85 meters per second, that means for every second that passes, this puppy will be 4.85 meters along. So to find the displacement, or how far away it is from this x reference, we can multiply 4.85, the velocity, by the amount of time at some time when these two are equal, or right next to each other. So this, the position of the puppy at this random time, or not random time, but at this time when they're next to each other, has to be equal to the position of the car. To find the position of the car, we know that it's accelerating at 0.165 meters per second squared. we are going to use the kinematic equation. Kinematics is just so the position at the end of a given time, we're going to call that v, or x final, is equal to the initial position plus initial velocity, which here is 0 because at the start it's not moving, times t plus acceleration times time squared, or 1/2 acceleration times time squared. Now if we subtract the initial position of this from the final position, which is unknown, we get this, x final versus x initial. And this is the same thing as how far along this car has moved, because you're taking the x initial, which is at 32, minus the final x value at the end of this t, and that will just get you the amount, how far along this car has traveled. So we're gonna call this delta x, which is the change in x. So I'm just bringing this down, we have delta x equals v naught t, which is, this is initial velocity. This is actually equal to 0 because at the start this is not moving. So then if this is 0 times t, anything times 0 is just 0, which means we can just ignore this. So you go delta x, which is the change that this has moved, equals 1/2 at squared. But this value for delta x, this doesn't get us the position of this in regard to the x reference. It only gets us how far along this has moved. So to find the position with respect to the x reference, we have to add this value right here, which is 32 meters. So you're gonna add 32. And then, so this 4.85t, which is the position of the puppy at some time, has to be equal to 1/2 the acceleration, which we know is this, so that's known. Acceleration is known. Time squared plus 32. Now, if we substitute our acceleration in here, we put everything on one side, we'll see that we have a quadratic equation. All I did was I subtracted 4.85t, 4.85t. And we only have one variable, which is t. So then you have 0 equals, and then this times 1/2. So it's 0.165. We'll just go over here. 0 equals 0.165, which is the acceleration, which we had right here, times 1/2, and then we just fill in the rest that we already have written. Simplified, this is 0.0875. Oh wait, no, this is just five. And this is t squared, and it's 4.85 t plus 32. Now, we can plug this into the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. And we can use a calculator for that. I actually have a calculator that we're gonna pull up. You can pull up a calculator. This is and this is A, this is B, and this is C. Okay, when we plug that into the calculator, we get values of 7.573, right? We'll just say 7. And so x equals, actually it's t. T equals 7.5, this is in seconds. T also equals 51.2142 seconds. It's a little bit messy. This is just saying that as the puppy and car move, because this is going at a constant speed, which is already fast compared to the car, that this will pass it once, but then the car will speed up because it's still accelerating, so which means that its velocity or its speed is always increasing, which means that eventually this car's speed will become a lot faster. So once the puppy passes, the first pass is at 7.57 seconds, and the second pass, when the car actually catches up to the puppy, is at 51.2142 seconds. We're just gonna round to that real quick. Now the question asks us, What is the distance traveled by the toy car from the time that the puppy catches up with the first time, then when the puppy catches up with it the second time? So we don't know the distance yet. We do know the time. And do you remember the thing that we found out before? That is delta x, which is the change in position. Oh wait, sorry. So we don't know what the delta x or what the change in position is yet, but we do know what the change in time is. So if we take one of these and finds the position at the first time, which is, let's say, this position, and then subtract it from this position, or subtract this position from the second one, we can get the total amount of distance that the toy car travels, because they're both traveling the same distance in between these 2 points, because the points are actually going to be the same. So we can choose either the puppy or the car from when we use the time. Now, because this is accelerating, we can calculate the two positions, but it's easier if we choose something that's constant. So first, we're gonna take this second position, which we know is the later one. We're gonna find that delta x, or the position with respect to the x reference point. Then we're gonna subtract it from the second x, or second time, which would be the first pass. So we're taking the second pass position and subtracting it from the first pass position, which means so to find, we have the time and we have the velocity. So to find displacement, all we need to do is multiply the time it takes or the time the thing is going at that velocity to find the distance it traveled. So we can take 7 point, we're gonna start with the larger one, 51.2, is that a 1? It is 1. 21 times 4.85. Then we're gonna subtract that from, we're gonna do the same thing again, take the time, multiply it by the velocity or the speed. Which is 4.85. And you'll notice this makes sense because this is in meters per second. We're multiplying by the time, which is seconds, and we end up with meters, which is the displacement. So let's put this through the calculator. Okay, when we put this through the computer or the calculator, we get a total displacement of 211.7 meters. And this is the total distance that the toy car travels in between both passes. Part B talks about, okay. So if this is asking at what speed instead of 4.85 will the puppy only catch up to this once. Now, if the puppy is traveling at a slow enough speed, it could never close this 32-meter gap before the car starts going at a velocity higher than the puppy, in which the puppy will never catch it. But if the puppy can pass the car, like we did in the first problem, it'll go twice. So it's asking, what is the velocity that the puppy needs to go at, where this will just pass once, and then the car will just start going at a higher velocity. Now, do you remember our quadratic equation? It was 0.0825 t squared. This is just what we had from the last problem. Minus 4.85 t plus 32. Now, this quadratic equation, because this is right here, this was this 4.85 up here. Now, we can just substitute this in. We're working with an unknown velocity. Let's call it v0, which means that this here, we're gonna put a v0. Now the last one, it had two solutions, meaning that it had two roots, but we only want to get one root out of this equation. So we want to find out what value for v0 gets us only one root. Now, we know that this is parabolic, so it's going to be like that. And if the x-axis is like that, it's going to have two roots. If it's like that, we're going to have no roots, no real roots. We want to get it so it only has one. So how do we do that? We use the discriminant. B squared minus 4ac. Do you remember in the quadratic formula, which is it's that, or b squared plus or minus square root of b squared minus 4ac all over 2a. Except the discriminant only uses b squared minus 4ac. Now, how does the discriminant help us? If the discriminant is positive, then we know it has two roots. If it's negative, it has no real roots. If it's 0 though, it only has one. So, that does it. One root. So we want this to equal 0. So our b squared is going to be v0. Our minus 4a is right here, and it's multiplied by c, which is 32. And this has to equal 0 because we only want one root. Now if we put this whole thing, move that to this side, we then have 4 right up here. We then have 4 times our a value times our c value equals v0 squared. And we can just square root both sides. Then we get the square root of 4, 0.0825 times 32 equals v0. And when we put that through a calculator, we get v0 equals 3.25 meters per second. So this is the initial velocity that the puppy has to travel at in order to only catch up with it once. Let's move on number 2. Okay, second one. We have a massless string slung over a pulley, a massless pulley, and a frictionless pulley, with mass 1, which is 2 kilograms. Oh, I drew that way too big. Let me just make this bigger. And then mass 2. I don't know, we just label this mass 1, mass 2. And mass 1 equals 2 kg, mass 2 equals 5 kg. It also says that both masses are resting on the floor. Why did that erase? Both masses are on the floor. And then we have to calculate the acceleration of each mass relative to the floor if, for problem 1, we'll say this is I, is when this pulley is being pulled up with 60 newtons of force. So if this is being pulled up with 60 newtons of force, what are each of these blocks' accelerations? Now, let's just start with free body diagram. We have, on each string, because this is being pulled up with 60 newtons, each string is being pulled up with 30. Because there's 2 strings, so both of them go up with 30. Because the whole thing is being pulled up with 60 newtons. Okay, for mass 1, we have, it's being pulled down by gravity, which is mass 1 times gravity. We know it's being pulled up with 30 newtons of force. But it's also, once this is lifted, mass 2 will be pulling on the pulley up. So we have, so mass 2, because the pulley redirects the direction, mass 2 is basically, the weight of mass 2 is pulling up on mass 1. And vice versa, the weight of mass 1 is pulling up on mass 2. So to this free body diagram, you have to add vector that says mass 2 times gravity. Now we do the same thing for mass 2. It's gonna have gravity pulling down on it, which is mass 2 times gravity. And it's gonna be pulled up with 30 newtons of force because this is broken down into 2 components. 30 newtons. And again, this is going to be pulled up because of this weight going around the pulley. This is going to be pulled up on by M1G. Now, Newton's laws tell us that force equals mass times acceleration. Well, we have the forces and we have the masses. So in order to find acceleration, we can say that the sum, we also have to define our axes. This is gonna be x, this is gonna be y. So the sum of the forces in the y direction, so we're only going up and down. This just means sum. For mass 1, we're going to start with mass 1 first, is equal to 30, this is going in the positive direction, so 30 is going in the positive direction. We're just adding up all of our forces on our free body diagram. And notice that this is pointing down, so this is going to be negative, because we defined y positive being in the up direction. So these two will be positive, and these two will be negative. So we add our forces, because forces equals mass times acceleration, which is 30 plus m2g minus m1g, because this is negative, equals mass, and we're doing mass 1, so mass 1 times acceleration. Now we can set that up for forces in the y direction of mass 2. Now we have 30 newtons in the positive direction and mass 1 times gravity in the positive direction. So we have plus m1g, and we're subtracting m2g because this is going down. And this is going to be mass times acceleration, which is, we can say that this is acceleration 1, just to distinguish. Mass 2 times acceleration 2. Now we know mass 1, no gravity, we know mass 2, we know gravity, and we know mass 2. So we know everything, we just solve for acceleration. Let's isolate the variable first. So 30 newtons plus mass 1 times gravity minus m2g divided by m2 equals a2. All I did is I divided both sides by mass 2 to isolate acceleration. And I'll do the same for the other side. 30 plus mass 2g minus mass 1g, all divided by mass 1 equals a1. Now before I plug in and solve, why don't we set up number 2? Number 2 is the same thing, just instead of the 60 newtons, we're going to have it being pulled up with 125 newtons. It's the same thing, just that this is going to be half of this. So each pulley, or each side of the pulley is going to be pulled up with half of 125. So we're going to go 6, 62.5, going up on this side, and 62.5 going up on this side. Hold on. We can use a calculator to check. Yep. So if we draw our free body diagrams again, we have the same thing, m2g, this is for mass 1, and m1g pulling down. It's the same thing that we did in the last problem, except instead of 30 newtons, we have 62.5. And So we can just set up these two again. And we have the sum of forces in the y direction for mass 2. It's going to be 62.5 going up, along with this for mass 2. So m1g. Again, this is because mass 1 is pulling down on this side, which pulls up on this side. Minus m2g equals m2 times acceleration 2. Actually, we're going to call this acceleration 3, just because we haven't solved for this yet. And then we can do that for mass 1. Sum of the forces in the y direction for mass 1. 62.5 plus m2g, because right here, it's being pulled up here. And then we subtract m1g. This is equal to mass 1 times acceleration 4. We can isolate I'm just subtracting by mass 2 on both sides. A 3. It's a terrible 3. Okay, now we have everything set up for all 4 accelerations. We can just plug into the calculator to find out. Let's do also just 30. Mass 1 is 2. So then you got acceleration 2 equals 0.1114. I just plugged in 2 for mass 1, gravity is 9.81, and mass 2 is 5. Then I divide that by 5. I get this. This is in meters per second squared. And then for 1, okay. And then for A1, we get 29.715. I like using this calculator. We can do this for this one. we get acceleration 3 as 6.614. Oh, so hard to use. Next one. Yeah. Then we have acceleration 4 as 45.97. Now, to answer the question, acceleration for mass 1 is acceleration what? 29.7. 29. Yeah. Acceleration for mass 2 we found is 0.114 meters per second squared. That means units. This is so acceleration for mass 1 is our 45.97 meters per second squared. Acceleration for mass 2 is 6.614 meters per second squared. And there we go.